Hey, let's talk about the radian ring today on the unit circle. It's the second ring of the unit circle. So we've already studied the degree ring. We've cruised around the unit circle and went around first in 45-degree increments and then in 30-degree increments. So here's where we've been. We've got a unit circle. It's called the unit circle because it has a radius of 1. And we've created these slices of pizza that are all not equal in measure. Again, the first pieces were of 45-degree increments and then 30-degree increments past that. That was the degree ring. Today we're going to talk about the radian ring. So you're asking yourself, well, what is a radian? Within the word radian, if I ask you, well, what do you think about? What word do you think about in mathematics when you hear the word radian? And you might think radius, and you would be exactly right. So take a circle of any radius you want, and in this picture the radius is that arrowed measure r, and take that radius length and wrap it around the circle. That creates a central angle. That central angle is known as 1 radian. 1 radian is that central angle. So I don't know how many degrees that is. You look at that and you go, I don't know, maybe it's 50 degrees or something. Well, there is in fact a conversion between radians and degrees that we'll talk about later. But I would ask the question, what do you think? How many radians could you lie around the circle and go all the way around the circle? That's the question I want you to ask yourself at this time. How many would it take if you just get visual like the song says and cruise all the way around the unit circle? How many radians would it take to go all the way around there? Let's take a further look at this. Again, here's our unit circle with radius 1. Let's investigate this a little further. First of all, think back. I know the circumference formula for any circle. The circumference of any circle has formula 2 times pi times radius. And if I wanted to figure out the circumference of the unit circle, I know the radius is equal to 1. So I'd have 2 times pi times 1. Simplified, the circumference of the unit circle is equal to 2 pi. 2 pi. Let's think about this further. 2 pi is equal to 2 to about 3.14. That leads us to about 6.28. I'm curious to know, what number did you get when you contemplated how many radians would be required to go all the way around the unit circle? Maybe you said it was somewhere around 6. That would be an impressive educated guess. Know that 6.28 is about 6 radians. Let me show you further here. This is what we started with. There's 1 radian, and let's cruise around the block. There's a 2nd radian. I'm giving this my best college try. There's a 3rd radian, a 4th radian, a 5th radian, and a 6th radian that goes a little beyond all the way around the unit circle. Check it out. 1, 2, 3, 4, 5, 6 radians. 6 radians. Yeah, we're going to piece this puzzle together at this stage. Check this out. There's our unit circle with radius 1. If we went all the way around the unit circle, we start at the same start line. We have 0 radians, and all the way around the unit circle would be 2 pi radians. 2 pi radians, or about 6.28. 6 radians and a little bit more. Gets us all the way around the unit circle. So I would suggest here cutting this up. If all the way around the unit circle, all the way around that racetrack, if I started up my car and I went all the way around that racetrack, I would be curious to know, how many radians did I go? And you'd say 2 pi. All right. How about halfway around that racetrack? If I started up my car and I went halfway around that racetrack, how many radians would I have gone? That would be pi radians. So we're kind of cutting this up the same way we did with degrees. How about the halfway point between 0 radians and pi radians? We would call that half of pi, or pi over 2. Let's go in between again. How about between, what's dead in between 0 radians and pi over 2 radians? Oh, what would be between 0 radians and you go to pi, and then you go 1.5 pi's? That's 3 pi over 2. 3 over 2 is 1.5, right? Now we're going to go in this pi over 4. So dead in between 0 and a half is a fourth, right? So between 0 and pi over 2 is pi over 4. In the second quadrant, you're looking at the midpoint between a half and 1. What's dead in between 1/2 and 1? That's 3/4. We call that 3 pi over 4. Over here is going to be 1.25 pi's. That's 5 pi over 4. In the fourth quadrant, we'll have 1.75 pi, also known as 7 pi over 4. All right? Those are the easy ones. And again, just like we started with degrees, we went in those 45-degree increments. Now, like degrees, we went in 30-degree increments. We're going to go in pi over 6-degree increments. Yeah, so this first measure we see is going to be pi over 6. And the remaining radian measures, you're going to use a strategy. I call it the sixth sense. When I first introduced the unit circle, it was a decade ago when this movie called The Sixth Sense came out, so everyone knew what I was talking about. But if you have a sixth sense, it's real easy to fill in the remaining radian measures that you're missing here. Okay? Here's what I mean. It's so easy just to say, hey, this first one is pi over 6. Then every pi over 6 radians, or every increment of 30 degrees, you're simply going to count. You're going to go pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. And whenever you get a fraction that can be reduced, reduce it. So here's what I mean. You started with pi over 6. The next one is 2 pi over 6. Well, that can be reduced. Cut them both in half, and you'll get the measure that you'll see in the unit circle, pi over 3. The next one is, let's see, pi over 6, 2 pi over 6, 3 pi over 6, which can be reduced. If I cut both those numbers in half, of course I get pi over 2, which is already shown. Pi over 2 is already shown. The next one we see is 4 pi over 6. That can be reduced. Cut them both in half. You'll get the measure you see in the unit circle, 2 pi over 3. Let's see, we've gone pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. The next one, you would agree, is 5 pi over 6. That can't be reduced, so I put it right in there. 6 pi over 6 is just pi in disguise, no mystery. Keep counting. 7, oh, those both reduce, you get pi. Yeah. This is 7 pi over 6. I know the next one is going to be 8 pi over 6, but reduce it. Cut them both in half. What will it be? Say it out loud. The next radian measure will be, I agree with you, 4 pi over 3. Don't get ahead of yourself now. Remember, you've got 9 pi over 6, which when you reduce it will be 3 pi over 2. That already exists. Let's see, 8 pi over 6, 9 pi over 6. Here comes 10 pi over 6. Cut them both in half. 5 pi over 3. This is making sense to people. And the last one we have is 11 pi over 6. 11 pi over 6, followed by, of course, 12 pi over 6. So this is how you cruise around the unit circle in radian measure. Again, if you know all the way around the horn is just the circumference of the unit circle, well, the circumference is always offered by formula 2 times pi times radius. The radius is 1, so I know this is where it starts. If you go, gosh, I can't remember how to do the radian measure. It starts with the circumference of the unit circle, it's 2 pi. And now just start breaking that down into portions, fractions of 2 pi. And take care of the 45-degree increments first. Then use the sixth sense and create all those 30-degree increments. You'll cruise around that horn and hit a home run. That'll be no problem at all. Just remember that when you go pi over 6, 2 pi over 6, 3 pi over 6, etc., oftentimes you're going to get a fraction that needs to be reduced. So reduce it. And you will have at that point the second ring of the unit circle all completed in radian measure. So at this stage, you should be able to draw your own unit circle. You should be able to cut that thing up into appropriate sized pieces of pizza. You should be able to write down the degree ring and the radian ring. That's pretty impressive so far. 2 out of 3 rings. Now the toughest ring is yet to come, but we'll get to that in the next video. I think you're doing well. Keep rolling.